Hi everybody. Now we're going to be dealing with goal 13, which is polynomials in standard form, and then knowing the parts of those polynomials. The main thing that you really need to know for this objective, this goal, is how to rewrite these in standard form. Standard form generally looks like this. We have ax cubed plus bx squared plus cx plus d, and this can go on and on to be as big as we want it to be. But generally what you need to notice is that it's in descending order, meaning that it starts with the highest degree at the beginning and it goes down to the lower. So we have 3, 2, 1, and then there's no exponent attached here. The parts that you need to know are right here in the very, very front, this letter A. Once it's in standard form, this portion is called your leading coefficient. The value over here that has no variable is known as your constant. Okay? So when we look at an example like this one right here, we have negative 5x squared plus 4 minus 7x cubed plus 2x. First thing we have to do is rewrite this in standard form before what any of the parts are. Okay? And so when we look at this, let's break these into separate terms. We take the number, the sign, the variable, and the exponents that go with it. So we have a negative 5x squared, a positive 4, a negative 7x cubed, and a positive 2x. So there's 4 separate parts. Put these in standard form. So we're going to go descending based on the degrees. Well, the largest degree, largest exponent in this is a 3. So the first term is going to be negative 7x cubed. Okay, we've taken care of that. The next one that we're going to have is going to be negative 5x squared. The next one's going to be a positive 2x. And then the last one's going to be a positive 4. This looks much more visually appealing than the one up here because it went 2 and then no variable, or no exponent, and then 3 and then 1 exponent. This one goes 3, 2, 1, and then no exponent. The leading coefficient we said is the number that's directly in the front, just the number, not the variable and the degree, just the number. So the leading coefficient for this is negative 7. You're going to learn later that that value tells us a bunch of things, such as if the graph itself is wider, narrower, if it flips, the behavior of the graph, things like that. Classifying this, let's go down here to classification. There's 4 different kinds of classes that we might have. There's monomials, binomials, trinomials, and polynomials. Monomials, an example of this would be like if I have 3x. There's just one term. A binomial is going to have it's going to have 2. So it would be like 3x plus 4. A trinomial is going to have 3 parts. So that would be like x squared plus 3x plus 4. And then a polynomial is going to have many. So it would be like x cubed plus x squared plus 3x plus 4, or anything beyond that. So 1, 2, 3, and then 4. So when we go up to this problem and we're going to classify it, it has 1, 2, 3, 4 terms to it. That means the classification would make this a polynomial. And then the last part that you need to know for these is the degree. I've been saying it. The degree is always known as the largest exponent. So when we look at this, we have a 3, a 2, a 1, because there's a 1 right here, and then there's no exponent, so the 3 would be the largest degree. So this is a 3rd degree polynomial with the leading coefficient of negative 7. Hope this helps. Let me know if you need more examples. I will send some to you.